Hey, welcome back to Lesson 31, which is on polarization, an interesting effect that light has when it travels. Now, EMR is basically a bunch of waves kind of shooting out in all directions. Illustration 1 is trying to show that, representing it traveling left and right, up and down, and diagonal, and so on. Now, me personally, I like to think of a merry-go-round. A merry-go-round filled with ninjas with throwing stars. So you can imagine sitting above this merry-go-round going round and round with horses on it, and on every single one of these horses is a ninja with throwing stars. And all of a sudden they decide to throw their throwing stars up at you. Now they're not just all going to come traveling in a single straight line, they're going to have different angles and different directions. That's really what light is doing. We call this unpolarized or non-polarized light. Let's take a look at this in an example in the form of an applet. So over here we have an applet. If I start it, we can see the representation of waves kind of traveling in all sorts of different directions. We've got a black, a red, and a green wave, and they're kind of going in the X, Y, Z kind of plane here. So all over the place. This is kind of how light would be, or EMR, or throwing stars from a ninja. The light here is unpolarized and unfiltered. Now what polarization is a way of filtering that light so that it only travels in one plane. Jumping to this applet here, we can kind of see the same example. Here we can see the blue, green, and red light hitting the polarizing filter, but after it strikes the filter, it's restricted to one plane, straight up and down, and that represents the red waves. Now an interesting effect occurs when you rotate one of the filters. So if I look at the second filter here and start to rotate the angle, you'll notice that eventually it actually cuts out or stops even the red wave. If I continue the rotation, we can see that we actually get it back, and again, eventually we're getting it down to 0. What this means is if you have two polarizing filters at 90 degrees to each other, they can completely cancel out or block waves. It's like light is trying to squeeze through two bars, one aligned vertically and one aligned horizontally. As it can barely squeeze through the vertically aligned bars, it then smashes into the horizontal bars, which really prevents it from traveling through. You may recall this demonstration with the two round polarizing filters from class. That effect is kind of demonstrated here if I rotate these filters. We can see through the rotation here that when it's 90 degrees, this little middle section here is blacked out. And when I rotate it back, we can see that that middle section there becomes clear again. So 90 degrees, no light can get through. Basically the same orientation, now light can get through. And that, my friends, really summarizes polarization filters and the process of polarization. There's not a lot there to it, just simply a little bit on the orientation of the waves. Well, that's it. We'll see you on the next lesson.